Well, in this screencast, we'll take time to look at a couple of examples just to make sure we know how to set things up. I will take pauses so that you can hit the pause button and try some things out on your own, just to make sure we know what we're doing. It is helpful if we, it should be example 3, shouldn't it? If we watch the other video, it's example 3. So let's find the arc length of the graph of y equals x cubed over 12 plus 1 over x on the interval of x values from 1 to 2. So hit the pause button, set up that arc length integral. The arc length integral runs from the left side to the right side of our interval from 1 to 2, square root 1 plus derivative squared dx. What's the derivative? Well, 3 comes down in front. This is x to the negative 1. There is probably some algebra we could do to make this work out very, very nice. But you should use your calculator to evaluate this. If you hit the pause button, then you can make sure that your calculator does it right. And otherwise, I think I've stalled long enough. That's about the arc length. And if you were to graph it, it makes sense. One other. Let's find the arc length of the graph of y equals x to the 4th on the interval of x values from 2 to 6. So just to give you an idea, 2 to the 4th is like 16, and 6 to the 4th is like whatever 36 squared is, right? 1296. So that's a difference of 1280. That's a difference of 4. You're looking for something that's about 1280. That's how we'll know that we're right. Take a moment, hit the pause button, set it up, use your machine. It's an integral from the left side to the right side, the square root of 1 plus derivative squared dx. There is no nice way to do this. We use technology to figure out that that's the integral to 3 decimal places. These are things we have to be able to do. On the upside for you, there aren't many ways I can make this much more difficult than this. So I hope that this is good help to you and that you are able, by practice and interaction with the mathematics, to learn it well.